Well, welcome to episode 56 of the High Tech Forum podcast. Today's guest, Dr. Lisa J. Porter, is one of America's most distinguished science and technology leaders. Her biography is too amazing for me to do it justice here, so let me just hit a few of the high points. She graduated from MIT with a bachelor's degree in nuclear engineering in 1989, an interesting time in our nation's history. Earned her doctorate in applied physics from Stanford in '94, received the Office of the Secretary of Defense Medal for Exceptional Public Service in 2005, the NASA Outstanding Leadership Medal in 2008, the National Intelligence Distinguished Service Medal in 2012, and the Presidential Meritorious Rank Award in 2013. So pretty well decorated. She was the founder of YARPA, which is basically the security services version of ARPA, the Advanced Research Projects Activity. It's been described as essentially a real-world version of Department Q in the James Bond movies. And she herself has been described by Wired as if you picture Q from James Bond as a tall woman with an American accent, you'd have Lisa Porter. I don't know if she likes that or not. She served as Associate Administrator for Aeronautics Research at NASA, actually doing rocket science, and as a Senior Scientist in the Advanced Technology Office of DARPA before that. And she has private sector experience with Teledyne, In-Q-Tel, and her current job as co-president, co-founder of LogicQ. And before LogicQ, she was Deputy Undersecretary of Defense for Research and Engineering and established technology modernization priorities for the DoD. She first came to my attention at the Silicon Flatirons event where she delivered a keynote on zero trust architectures for network security. That talk was actually so insightful and so important that it prompted the Institute for Telecommunication Sciences at NTIA, which is the government's main spectrum research lab outside DoD, to make zero trust the central theme of this year's International Symposium on Advanced Radio Technologies Conference. So welcome to the podcast, Dr. Porter.
Well, thank you. Thank you very much. It's nice to be here.
I'm really glad to have you. Really excited. Your presentation at the ISART conference that I just mentioned was pretty much, I mean, your ideas were the basis for the theme of the overall conference this year. And, you know, people that your co-panelists on the deal that you did said that your presentation at ISART on zero trust was to them really the highlight of the conference, and did the best job of kind of framing and explaining to the general public, or to the general experts on spectrum policy and security, what this zero trust deal is all about. So would I be imposing too much if I asked you to kind of recap that presentation?
No, not at all. I'm very quick to point out that, you know, these aren't my ideas. I've just spent a lot of time thinking about them and thinking about how they relate to the challenges we face in the national security community. So I appreciate all of the, you know, nice things you said about me, but really I just see myself as somebody who's tried to get people to think about these things the right way and be helpful in guiding that. So I'm happy to give you a recap. I would start off, whenever I'm talking to someone about zero trust, I remind them it's not a technology. It's not something you go and buy and sprinkle on top of your system, right? It's actually a fundamental philosophy, right? And it applies not just to networking and not just to 5G, which was kind of the context of my original conversation with you. It also applies more broadly to any kind of complex system, including things like supply chains and how you think about supply chains. So there's been a lot of, I shouldn't say a lot, but there's been some erroneous explanations out there about zero trust, and particularly in the popular media, people tend to, you know, give their opinions about what it really means. And I've seen people describe it as, well, it's not really zero trust, you know, it's more conditional trust. And, you know, you really have to be able to trust people to get things done and blah, blah, blah. And no, it isn't any of that. It is exactly what it says it is. It is really about embracing the notion of zero trust. The notion that trust is a vulnerability and it can be exploited. So you have to eliminate trust as your goal when you're designing a complex system in the real world. And that makes people uncomfortable because when I say that, what I mean is you can't say you're designing a zero trust network or system and at the same time say that you want trusted suppliers and trusted vendors and
Right.
trusted users. Those things are incompatible. And you hear people all the time saying that today, right? You hear that from people in very senior levels of government trying to say that they're doing both things. And that indicates that they don't really understand what zero trust is. Zero trust is you don't aspire to establish trust because you recognize that once you say something is trusted, you've introduced a vulnerability into your system. And so that's really the essence of zero trust. Now, I didn't invent it, nor was it invented in 2010, nor was it invented in 2004, as you'll see some of these histories of zero trust written up, in the popular press. It's actually, as I said, it's a philosophy. And it's something that's very inherent in the intelligence community. So, and you don't have to be in the intelligence community to know that. If you've ever seen a good spy flick, right, you know that that's kind of inherently their culture, right? Trust no one. Now, ironically, and the reason I get, fairly passionate about this is when I ran IARPA, when I was the first director, I stood up IARPA, it was 2008, January, February timeframe. At that time, the government, in particular, national security community, was really concerned about cybersecurity. It had suddenly become something really important for people to think about. And the national security community was asking, how do we build secure cyber systems? And in fact, they were so anxious to solve that problem that they established something called the Comprehensive National Cybersecurity Initiative, I think is what it stood for, the CNCI. It's a very popular acronym at the time, billions of dollars, all focused on how do we build secure cyber systems. Now, there were people like myself, and again, it wasn't just me. There were people like myself who were raising our hands and saying, that's the wrong question. And if you focus on solving that question, you're actually going to be solving the wrong problem. The problem you should be looking at, or the question you should be asking is, how do we ensure that we can operate effectively and conduct our missions when we're using systems that are going to be inherently not secure? We have to accept the reality of that and figure out how to operate regardless of the fact that these systems are not secure. People didn't want to hear that at the time. They didn't like that. It was uncomfortable. It was inconvenient. It was so much nicer to think you could build secure systems. And so as a result, we ended up with what are known as perimeter defense models, right? So lots and billions of dollars were spent in establishing perimeter defense models. And then unfortunately, what happened was this became less of an academic concern and more of a reality when Edward Snowden took full advantage of the perimeter defense model. And we all know, at least in the intelligence community, the impact of that was significant and grave. And he was able to do more damage to national security from being inside as a trusted individual inside the moat than any untrusted individual could have done outside the moat. And that really should have driven home the point of what zero trust is really all about. That should have been a moment where people recognize, this concept of trying to establish islands of trust and people of trust. And once you're vetted and once you're inside, you're good to go. That needs to be abandoned because that introduces a huge vulnerability. That should have been the aha moment. Unfortunately, we're now sitting at a point, right, in fast forward about 10 years, and here we are, we have leaders in national security, and this is, bipartisan. It's not about what party you're a part of. It's not whether you're in the legislative branch, executive branch. It's all across senior leadership. You see people championing this desire to have trusted partners, trusted vendors, trusted connections. They're missing this point, right? And so the more you pursue that, the more you're actually, even though of course no one intends this, you're actually creating a more vulnerable scenario where you're making yourself more vulnerable to the threats that you think you're protecting yourself from. So I've been very vocal about this. I'm trying to get people to understand you got to be all in on zero trust. And it means, of course, you really have to understand that you have to eliminate talking about trust as a goal. And Richard, one of the things that I run into when I talk about this with people, and it came up at the ISAC conference, and I was glad someone asked, is people hear this explanation and they say, oh, okay, well, are you saying then that we should just work with anybody since we can't trust anybody? And I sort of use the logical example of A implies B does not mean B implies A, right? So
Mhm.
the answer is, of course not. If you know somebody can't be trusted, if you know a supplier can't be trusted, if you know someone, if they connect to your network, is going to try to wreak harm on you, of course you don't allow that. But just because you decide not to allow bad actors into your system does not make your system trusted or more secure. That's really the point, right? And I think that's the big logical or cognitive disconnect that people are missing, and it's very important. So once you start to embrace what zero trust is really about, then you realize, okay, how do I think about sort of applying this philosophical approach? How do I embrace this? Okay, I'm on board. I get it. I can't trust anyone. I've got to think smartly about how I design my systems. What do I do? And I'm not going to go into all the details. It's very, you can read the NIST special publication that just came out if you want to read really good details of how to do this for a network. But regardless if you're talking about a network or you're talking about a supply chain or something else, there's going to be two elements of any zero trust implementation at a macro level. And the first is the way you approach your system is you've got to think about a data-driven, quantitative approach to how you assess your risk and manage your risk. And you're going to make decisions based on the data that you have available and an understanding of what that risk is as you calculate it and how you want to assess it and manage it. And that's a dynamic process. So you may come in and say, I have this device and I want access to this data in your system. And my risk assessment tells me it's okay at this time for the thing you're asking for and the device you're using. That doesn't mean you're going to have access tomorrow to a different set of data using a different device, right? It's very dependent upon the situation. Or I might learn new things about you tomorrow that I didn't know today. So I have to be able to change that decision and say, okay, now the risk is higher, I'm less willing to engage. So it's a dynamic process, it's a learning process, it's data-driven. And then the second part that's just as important is recognizing that despite the fact you put in a nice quantitative assessment technique and methodology for risk, you're going to make mistakes. You know that risks are going to materialize. So you have to put in place mitigation that allows you to minimize the impact of any risk that does materialize, right? You want to be able to localize it. You want to be able to minimize it. You can't eliminate it. We can't operate in a zero risk environment. We just want to be able to mitigate risk, right? There's a difference between mitigating risk and eliminating risk. And you want to be able to mitigate that risk as much as possible. And so once you realize that that's really what zero trust is about in terms of implementation, you say, okay, well, that's hard, but that's something we should be able to do. Mm-hmm. And at least it gives us the right mindset to recognize that we're always assuming that something might go wrong, and how do we design systems that give us that resilience to address that reality versus trying to do something that actually leads to an architecture that makes us more vulnerable, right? So that's kind of the essence of zero trust, and hopefully I didn't go on too long, but that was basically what I tried to make the point of at the ISAR.
No, I mean, that's great. I mean, the nice thing about perimeter defense as a concept is that it's so simple to implement, right? I mean, you just have a user ID and a password, and then once somebody gets into or logs into the system, then
right.
You don't have to think about security anymore, because security is really kind of annoying, right? I mean, if you're a system developer, or an application developer, you want to think about your mission and your task and all the cool things you can do, the capabilities you can give to users, and the data that you can gather and all that. And security, another thing like that is privacy. It's just annoying, right? But in real world implementations, those things end up sort of being central to the value of the application in terms of the enterprise's role.
That's right. It's more annoying when the system goes down because you didn't follow a good process, right? And so it is like everything in life, it is a trade. Yeah. It's uncomfortable because it's not simple, right? When you talk about the real world, it is ugly and it is messy, and you have to embrace that and say, all right, we have to deal with that as best we can.
Well, I think I go back to I wrote a blog post back in January after the Silicon Flatirons thing, and and I made some sort of, I think I covered kind of some of the main points, at least that you discussed today, like this sort of delusion about Huawei. Right. That if we just get the Huawei and ZTE out of our networks, then everything's going to be rosy.
Exactly.
And to me, it's, I mean, this is sort of a contrarian way to look at it, but to me, Huawei's a challenge. And so, to me, I think you're not going to eliminate Huawei from the world's global
Correct.
5G networks,
Correct.
or even, you're not going to eliminate Huawei from the world's IP networks, because they're a, really significant supplier of internet routers, on pretty much they do everything that Cisco does, plus they do all the mobile stuff,
Mm-hmm. Mm-hmm.
which is sort of a missed opportunity, I think,
Mm-hmm.
on Cisco's part for not going into that. But so they're a test case. I mean,
Yes.
if you can, they represent a challenge in terms of their attempt to capture data, perhaps compromise data, whatever. I have no doubt that China has bad intentions towards the U.S. and the
Right.
rest of the Western civilization. That's just sort
Right.
of they want to be top dog, just and
Right.
we're top dog right now, and
Right.
they can't do that without it's competition. I mean, it's like the Nuggets and the Clippers. Somebody had to win and somebody had to lose. Um, but at the same time, if I mean, like you said, if they have malicious intent, and they've proved over and over that they have malicious intent. And it's sort of like having a troll on your, on your Facebook page. You just block them. I mean, you say,
Right.
okay, enough. I'm not gonna deal with that. But they're still going to be around. So,
There's still going to be other avenues for your network to be vulnerable. And I like to point out that the Russians haven't built any of the hardware that they've been exploiting effectively, right?
uh,
So they are a good proof point of what I'm saying. And by the way, the Chinese don't need Huawei to exploit either. So when you eliminate Huawei and ZTE, okay, that's good, fine. But you have not solved your problem. And convincing and thinking that you have, of course, is the real vulnerability.
mm-hmm.
Because now you've let your guard down to other alternative avenues that all kinds of threats can take advantage of.
Yeah,
So, that's the challenge.
it's so nice to lull ourselves into a false sense of security. Like, oh, we've met the enemy and we've defeated him, and now we're,
That's right. That's right.
yeah,
And
but
your point is, it's a really good one. I tried to make a lot in my former job in the Department of Defense, and the DoD really did rally behind this point. We have to operate in the Department of Defense. I shouldn't say we because I'm no longer there. The Department of Defense has to operate regardless. We don't get to pick, right? It's not like it gets to pick where it has to go and deploy.
mm-hmm.
They deploy where they need to deploy, and some of those places will, as you said, will have Huawei.
Mm-hmm.
And so can they would just say, no, sorry, we can't go there because they have bad equipment and infrastructure and there's bad guys there? Of course not. So if you design solutions that assume that Huawei's not there, that's your solution, right? Assume
Mm-hmm.
Huawei's not there. Now you got a problem.
Mm-hmm.
So instead you have to assume that your network is compromised, regardless of where you are and regardless of who has built it. That's what Zero Trust does. It's just assume there are bad guys, assume things are bad. Now, how are you going to operate? And you design solutions that can handle that. Now you're far more robust and resilient than if you design solutions that wished away that part of the problem, right? That's what
Oh, yeah.
we try to emphasize.
Yeah, so you stand up. We're fighting a war in Iraq, and we stood up a bunch of temporary wireless mesh networks after we blew up. The big cube that had all the base state, or sort of the central control point for the commercial networks that were already in Iraq. But you have to bring a dynamic risk assessment along with it. It's the mesh network doesn't just have to calculate routes and move packets around in the best possible way. It also has to be on the lookout for hazards.
That's right. That's
Yeah.
right. That's right.
Yeah, there was some interesting thinking that came out of, oddly enough, the National Renewable Energy Lab, which is close, in Golden, Colorado,
Yeah.
where
Yeah.
they were doing just took the assumption that there was no way and their concern is that with the utility grid, the security and stability and resilience of the electric grid, because that's obviously going to be a target for attackers in any kind of conflict scenario.
Mm-hmm.
And they determined that one of the things they needed to do was just sort of have an understanding of what normal behavior looks like on the network, the
Right.
data network side of the electric grid, And so when you find anomalous conditions, you know, it triggers some attention and gives you a clue that something might be going on.
That's right. That's right. And in fact, in the zero trust architecture, like for example, the document that NIST just put out last month, they talk a lot about the behavioral analytics as a tool that you use, and you
Mm-hmm.
get smarter as you go. Again, nobody's claiming it's perfect, but this is the attempt to say, look, let's use all the information that we have. Let's continue to improve our approach to how we use that information. And you know, the example you give, anomalous detection, this is something that people are getting better and better at.
Mm-hmm.
You get more data, right?
Well, and it's got to be dynamic too, because what
It's dynamic.
normal changes.
Normal changes. You're absolutely right. And the threat will respond, right? You can
Mm-hmm.
never assume that, like you said, I like to say there's no finish line, right? There is no
Uh-huh.
finish line in any of this. So you've got to keep pushing and keep trying to stay ahead, but recognize that there's always threats out there and they're smart and you
Mm-hmm.
can never let your guard down,
Mm-hmm.
right?
And so what do you say to people who say, well, you're just saying we should play a game of whack-a-mole here and we can never solve the problem?
No, I don't think it's a game of whack-a-mole. It's a game of, look, the reality is there are always going to be threats. And
Mm-hmm.
you'd be foolish to think you can ever get to a point where you've, quote, won, right? We've made that mistake as a country in the past.
Mm-hmm.
And we've seen what happens when we let our guard down.
Mm-hmm.
And so we've always got to be prepared to address a threat by thinking strategically. So I don't think of it as whack-a-mole. Whack-a-mole is where you find yourself in a defensive crouch because you haven't thought strategically. And
Yeah.
now,
Right.
as a course of last resort, you're just whacking at stuff.
Mm-hmm.
Whereas strategically, you're saying, okay, I'm going to get out in front of this. I'm going to think about how I architect systems with these fundamental principles, right? Around assuming I can't trust anyone, assuming my network will be compromised, regardless of how smart I think I am. And I'm going to be able to operate through that, right? I'm going to be resilient. I'm going to develop tools and techniques that allow me to operate regardless of what gets thrown at me. If that's your focus versus I'm going to assume there's no bad guys because I'm just not going to allow them in, right? That's the problem with the prior approach. That was the assumption, you know, and that leads to devastating consequences.
Yeah, I think there's, you know, looking at this problem from the perspective of a technologist and someone who's develops technologies, there is kind of a star system in technology where we tend to give rewards to people that come up with the great idea for the new app, and in the network context, for you know, you make your network faster and cheaper than anybody else's, and you get the benefits.
Mm-hmm.
But it strikes me that part of what has to be done here in order to make these networks secure, and not just networks, but you know, applications, is that we have to treat the security people with more respect, you know, and kind of make them, because I mean, it seems to me that if they work as hard at making systems secure
Mm-hmm.
as hackers do at breaking in, that I think ultimately the good guys sort of have an inherent advantage because they're putting up the defenses, and once they've put up defenses, then the bad guy, the black hat guys, have to go figure out what kind of defenses you've put up before they can figure out how to exploit them. And while they're doing that, you know, you're nothing prevents the developers from putting up more defenses. So
Yes. So the key as a defender, of course, is to try to make the cost of being on the offensive side a lot higher than it is today, right?
mm,
I think most people would argue it's easier to tear something down than to build it up, and so it's usually easier to get into something, so to speak, and hack. But you want to make it harder for them, and you want there to be more punishment, right? And if they fail. So, and there are ways to do this. There are strategic ways of thinking about how you defend your networks, and defend I use in quotes because I don't want people to think perimeter defense. I want
mm-hmm,
them to think, okay, you know that your network is inherently a compromised infrastructure. So how are you going to use it knowing that? And what tools and techniques are you going to implement knowing that the bad guys are likely on your network and trying to get in and do things? Well, you're going to try to create a bunch of techniques through the zero trust types of approaches that have been proposed that again look at, okay, well, if they get in, I'm going to be able to localize them. I'm going to use containers, right? I'm going to use a lot of virtualization. There's a whole bunch of things, as you know, Richard, that people are talking about now. Those are the right kinds of thinking. So I'm actually optimistic on the technical side. I think the technical community has come a long way in 10 years. I think you see the cyber community really understands the fallacy of the approach they went down 10 years ago. And they've really embraced what I would call a zero trust approach. They've really embraced a lot of the features and elements of it. What you have to watch out for is the sort of policymakers who sit on top of that, who may not understand what the technical people are trying to do. I'm trying to be polite. And therefore can actually do harm, right? Because they can push them in the wrong direction, or they can fund the wrong things and not fund other things, right? So I think that's the challenge. Is there are a lot of smart people, and I think they've been more empowered, right? But I think you've seen people have these conversations that they didn't have 10 years ago. I mean, 5G, people talk a lot more about security, I think, than historically people had talked about. So there is a goodness to that. And it's how do you leverage that in the right way?
Yeah, I wonder if you have any take on the, I don't really see 5G as representing any kind of unique security threats that previous generations of technology didn't have. As the biggest security problem that I'm aware of in 5G is that there are some conditions under which it's possible to make a 5G base station revert to 4G mode of operation. And so what that means is that worst case, it's no better than 4G was. And that's actually, it's kind of a patchable thing. But to me, the stuff that gets really interesting is these systems like CBRS that have these database, spectrum assignment databases where we basically the database operator has to decide that such and such an applicant can be trusted to manage, a swath of spectrum. And as we make, we go further down the road of trying to share spectrum dynamically, there are a lot of opportunities for, I think unanticipated consequences.
Yes. Yeah. And I think that would be far less about malicious and just about figuring that out and how to make it work. Which is why I'm a big fan of the experimentation, which again, you probably remember from my talk that the DoD was really focused on, okay, let's experiment, let's figure this stuff out. Let's not pretend it's all solved. There's a lot of things we've got to figure out. It's all solvable. But you got to admit
we'd like
you
to
don't
think
know.
so.
Well, you're right. I shouldn't say all, but I would say a large majority of what people want to get after, if you put the smart people out there and you empower them to be honest, right? That's a big problem, right? People want to be able to declare victory too soon. And then they haven't studied the edge cases, right? And that's usually what gets you. And it doesn't matter what the situation is as an engineer, that. So allowing them to really experiment and wring out a system and not say, I'm going to prove my idea works, but I'm going to really explore where it works and where it doesn't and where it needs to be improved. And you're right, the dynamic spectrum sharing and CBRS, there's a 5-minute time lag, I believe, right? So what happens when you want to reduce your time lag to make things more dynamic and more responsive? And how do you deal with all of the challenges that are related to that, the compute challenges and the interference challenges that people are worried about? Okay, that's fun if you're an engineer, frankly, but you got to let the engineers get after it and do it in an environment where they're encouraged to be honest and truthful about the results. And there's a lot to be worked out. So as someone who's sat, and who has sat in Washington for longer than I'd like to have sat in Washington, I think the biggest challenge of this place is, people are so afraid when they say, I'm not sure what the answer is going to be. I need to go collect the data and really look at it. People want them to come back and say, I found the solution and here it is, right?
Yeah, right.
And they take the photo opportunity, if you will, and it goes on the,
check that off the list and,
yes.
go secure funding for something new.
Exactly. And so people have to be empowered to be honest and to pursue what I call technical truth, right? The real pursuit of technical truth is something that can be quite challenging sometimes, unfortunately, when you have a bunch of people who really, everybody has good intentions, but they don't understand that complex things require a lot of rigor and a lot of patience to really wring it out and understand it. And then, you figure out how to deploy it properly.
Mm-hmm.
blah, blah, blah. So, I think it's all something that if we don't do it right, yeah, we're going to have a lot of problems on our hands down the road because of the unintended consequences that we haven't explored.
Well, and we're kind of already there in some sense. I think the internet was supposed to be an academic experiment, right? I mean, it was, well, we'll just throw this thing together and we'll learn some things about how people use networks. We'll develop some cool applications, and then we'll discard it and we'll take what we learned and design the real network. And the real network was supposed to be something like the OSI, based thing, but it ended up just being too complicated, too enmeshed in politics, and they were. It was kind of a victim of bad timing. When you got a network that seems to more or less work, like what's the point? Why would you throw it away and replace it with some
Right.
alternative that isn't going to provide you with any discernible benefit for probably 20 years?
Right.
You got to wait till you perceive the need for
Right.
it.
Right.
But there's so many people that are worried about so many aspects of the internet. I mean, not the least of which is the effect it has on culture,
Mm-hmm.
on elections, on socialization,
Sure.
blah, blah, blah. But I mean, and those things are sort of inherent in the fact that you just have a communications medium that can be used by everybody everywhere to communicate with everybody everywhere.
Mm-hmm. That's right. That's right.
Hmm.
That again, it still comes down to the fundamentals. I'm a fan of Umberto Eco. I don't know if you know him, but he wrote The Name of the
Name of
Rose.
the Rose, yeah.
And if you read
Hmm.
that book, of course, it shows you the problem with the opposite extreme,
Hmm.
where you had the keepers of the knowledge, right?
Hmm.
And I would still choose every day and twice on Sunday. I would choose, open.
Yeah.
Everything, everyone should have access. And that means, of course, there's a lot of false information. And you're right, that creates, unfortunately, especially today, it creates an environment that can lead to divisiveness. And so as individuals, we also have to have a zero trust philosophy, right? We have to sort of say,
Yeah.
well, don't just trust everything because someone's saying it. Does that make it true? um, you know so that whole concept of a healthy skepticism, right, it should be
Hmm.
brought to bear on all aspects of life. That's my opinion. It
Hmm.
doesn't make you a cynic if you're a skeptic, right? It just means you're willing to question rather than accept blindly. I'm not going to trust you. I'm not, just because you say you're so and so, I'm going to vet it for myself. I think that's an attitude that, in general goes a long way. So
Yeah. My favorite piece of spy entertainment is a French TV series called The Bureau.
oh, I haven't seen it.
Oh, it's just marvelous. Yeah, you can watch it on, I think, on Amazon Prime
Okay.
through. Uh, but it's about undercover agents, and in the more or less final season of at least the part of it that was built around this one main character, they introduced the notion of remorse for like the things that an undercover agent, secret agent, has to do in order, to do their job. And there's some line about um, where one spy is criticizing another spy for finding the least little bit of decency in his opponent and then exploiting that, using that against him to destroy his life. And it's sort of the
Mhm.
basic premise is that what undercover ops do is they destroy other people's lives.
Hmm.
Well, they at least try to destroy the lives of other undercover ops, right? But there's a certain ambiguity, certain moral ambiguity, probably inherent in that sort of work, but something that needs to be done.
Yeah,
But
well, I've never been a spy, despite the Wired magazine declaring I was Q, which I did think was funny, by the way. But,
uh-huh.
but I've never.
Well, he wasn't so much a
uh,
spy as a spy enabler, right? I mean,
I
the
certainly
gadget.
have worked on technology to help, hopefully,
Yeah,
to help our intelligence community.
yeah.
But it really does come down to um, the uncomfortable reality is that things are gray and you can't. There's
Mm-hmm.
no finish line, right? That's really why I like the movie Charlie Wilson's War, right, where he kept
Mm-hmm.
saying, "We'll see," right? We'll see, because you think you know what the right answer is, and then things change and evolve, and you have to evolve with them. Otherwise, you end up creating a situation that's not actually a good one.
So,
So
yeah.
yeah.
Sometimes I wonder if skepticism is beyond the ken of like the people that are perhaps less educated and whatnot.
I,
But
you
it,
know,
It
I don't know.
occurs to me they're probably the most skeptical people of all.
Yeah.
I mean, in
Yeah,
some sense.
I don't actually think it's education. I just think it comes down to, taking stock of how you think about your decisions that you make in your life. Do you make them
Hmm.
reactively, or do you have sort of guiding principles that help you make decisions?
Hmm.
And I don't think it's a matter of how much quote education you have. I was very blessed, of course, to have wonderful education. But I came from middle class, first generation of people who were able to do that. So I can't say that it's about education. It's more about taking stock of how am I making decisions? And then that translates into how do I design systems, right? Am I designing systems with forethought about fundamental principles that are guiding my design principles? Or am I haphazardly putting a network together that's going to be terrible and easily exploited because I haven't thought it through, right? It translates. So I think it really comes down to strategic thinking, right? And both your personal and professional perspectives.
Yeah, one of the first jobs I had in software engineering was at EDS, where they had at the time they had a philosophy that when they hired someone to be basically to be a programmer, before they let them write any code, they had to spend a year working with the clerks who were using their systems, basically with the customer,
Great.
to find out. And they abandoned that because it ended up being too expensive. I mean, after a while, but the basic idea that if you see how people actually use the system and you understand that, then when you get to the point where you're the developer of the system, you have a fairly profound appreciation for the fact that things aren't necessarily the way they look on paper. And we're all these technologies, we're designing these technologies in spite of things like the Internet of Things.
Yep.
We're mostly designing them to be used by people to do things, to accomplish goals that people have. And you have to think about it in the context and more or less in a human context. And so
Right.
it's
No, that's
challenging.
exactly right. But that's part of what makes it exciting. And I think you're seeing people starting to recognize that now with, with the 5G use cases, that people are
Hmm.
really gravitating more toward machine to machine. And what's going to happen when we, interface with an IoT architecture that's already been in play, right?
Hmm.
So I think you're right. And I think that's, I mean, again, as an engineer, I see those things as exciting, but you're absolutely right. The more you get an understanding of how things are going to be used, the better you can design them, knowing, of course, that there will be use cases you haven't thought of. And people like
Hmm.
to throw out the Uber example, but it's a good one, right? People
Hmm.
didn't predict that. They didn't design for it. And yet it turned out to be a pretty good use for what was developed,
Hmm.
or GPUs, right? Those weren't designed for artificial intelligence either,
Yeah.
but
Right.
turned out
Right.
to be pretty good. So
Hmm.
all of that is fun, right? I think that's what makes, people worry a lot about the United States. You brought up China and Huawei, and I've never fallen into that camp of people who I do believe China is a very formidable adversary, and I do believe they are definitely trying very hard to unseat us, no doubt. But I've always believed in the power of the United States through our innovation and our natural tendency to ask questions and, wonder how things can be built and made better, that ultimately we will prevail. That we sometimes our own worst enemy, we get in our own way, right? We were just saying how sometimes our policymakers, in an attempt to help that, sort of end up putting up barriers to that. But I think ultimately, if we just allow that creative, sort of natural tendency to figure things out and empower people all over the place, you don't have to be born into a rich family. You don't have to have a PhD in this country. You can be pretty much anywhere and just use your brain and figure things out. And so when I look at 5G and I look at all the stuff that's going on, look, I mean, Richard, you've had different people that you've talked to. Look at the scale of people that are engaged in it, all
Yeah.
kinds of folks, right? And it's exciting. And so we
Hmm.
can't forget, we can't be fear bound or, so worried about bad guys that we're not allowing our own creativity to go forward and solve these problems. China will steal what we do. Absolutely. But, I'd rather they try, when we get to a point where they're not trying to steal from us anymore, we better ask ourselves what's going on,
Yeah.
right?
Yeah. Don't we have anything worth
We're no
stealing?
longer worth stealing from. That's the problem, right?
Hmm.
So
Well,
I'd rather be that, than
uh,
than the one trying to catch up. So, that's part of the message that we've tried to put out there when I was in the DoD is let's not get all hangdog about things. Let's own this the way we should, right, as leaders, and
hmm.
continue to charge ahead. And again, remember, zero trust is really a good philosophy in general. It's really about skepticism, if you want to get philosophical about it. Apply it to everything that you can, and don't take the shortcuts, right, that make you feel good, but they're actually really making you more vulnerable.
Yeah, it's comforting to think that there are authorities and rules we can follow that just sort of automatically make everything better. And if that were true, human life would be very different. But
Yeah, yeah,
yeah, it's not really that way.
not really
Well,
that
it's
way.
great. I mean, I think that one of the things that I've seen happening since you and people like you have been more or less touting, zero trust architectures is, and the importance of really thinking about security and resiliency and risk and harm mitigation in a more comprehensive and kind of more philosophical way. Is that I think you've made this a really kind of sexy engineering topic, and I think probably excited the imaginations of a lot of engineers to like, this could be the next big thing in
Mm-hmm.
computer science. Is
Mm-hmm.
that okay? We figured out how to build these systems that work well, that run fast, they're resilient, they make information available. We can analyze. We can. AI is just sort of, it's all practically a household. I mean, it is a household term these days. And like,
Yes, it is. Yeah.
every little thing, every little video camera claims to have some AI in it, every TV
Right.
set.
Right.
And so now it's like, okay, now let's figure out how now that we know how to do the good things, what's left to do, but look at how we prevent the bad things from happening.
Mm-hmm.
And
Mm-hmm.
I think that's actually going to be an even more exciting engineering challenge than just sort of figuring out how to move packets from point A to point B
I
ever
think it
was.
is. I think that,
Mm.
and again, good system engineers who design complex systems today, they would hear the way I describe the risk management, right, and the mitigation, and they'd say, well, yeah, any good system engineer designs a system that way, and they've always got their risk matrix handy, and they're always updating it because they're
Hmm.
always reassessing the risk based on data that they get, right, or time that elapses,
Hmm.
and they're always looking at their mitigation techniques and making sure they still apply.
Hmm.
So sure, what you're saying is just really good common sense. And system engineers, of course, love being system engineers because that's what it's really all about. Stuff's going to go wrong. So you've got to try to design as much as you can
Oh yeah.
to be able to handle that. And it's fun.
Yeah. I mean, my favorite thing to do with software back in the 70s was put counters in everywhere so I could measure everything that was going on and
Right.
understand,
Right.
when my assumptions about what was going to go on inside the system, when they were right, when they were wrong, and yeah,
Exactly.
had to
Exactly.
correct, yeah, collect the information, learn from it.
Right.
It really is all about learning and reacting and
That's right.
building
Learning
the
and being
next
willing to
generation on
evolve.
top of a sound foundation. Yeah.
Absolutely. That's really what it is. So that's the
Hallelujah.
fundamental philosophy.
Yeah.
Yep.
Well, I think we should start a religion.
No, no, we don't need to do that.
Okay. Yeah, I mean, it's been a great talk. I really appreciate your spending the
Sure,
time with us,
sure.
and I
We
think
got
even,
got a little philosophical on folks here, but I think it was fun.
well, I've got a degree in philosophy.
Good. There
I'm
we go.
qualified to do that,
Okay, good.
right? Well, and you're a doctor of philosophy yourself, so there you go.
Well, I guess you could say that, although it has nothing to do
Yeah,
with philosophy.
yeah. Okay.
Oh,
So, yeah, there you have it, folks. This has been episode 56 of the High Tech Forum podcast with Dr. Lisa J. Porter, talking about zero trust architectures and resilience in networks and computer applications. So, we do these podcasts on a more or less irregular basis, maybe once a week, once a month, depends on when the spirit moves us. So check in. Podcasts are available in all the places where podcasts are normally available, and like every other podcast in the whole world, we appreciate likes and reactions from audiences so that we know this is being heard. And we do enjoy getting ideas from the audience about guests and specific questions. So there you have it, folks. This is Richard Bennett signing off.